Okay, if we're going to talk about random variables, we need to have a definition for random variables and what a probability distribution is. So a probability distribution of a random variable gives its possible values and their probabilities. It's denoted P of x equal x, or some number. What is a random variable? Give some examples. A random variable takes numerical values that describe the outcomes of some chance process. Don't get these mixed up with your algebra variables where you solve for x, or you have y equal 3x plus 2, a linear equation, and you substitute values of x in for y. This is different. In these, we are assigning numerical values or giving it numerical values. So we're quantifying them. Some examples would be like if you were flipping a coin and the number of heads that came up, 0 would be for tails if tails came up, and 1 would be for heads. Or the sum of the rolls of 7 dice. Those are examples of random variables. Tossing the coin 3 times. And these are the possible outcomes. I could get heads, 3 heads. I could get 2 heads and then a tail. I could get a head, then a tail, then a head, etc., all the way down to 3 tails. Since there are 8 equally likely outcomes, the probability is 1/8 for any possible outcome. We're going to define our x, or our random variable, as the number of heads obtained. We will either get a 0, a 1, a 2, or 3 heads. How likely is x to take those values? Well, this is our distribution. 0, there's only one way to get that. To get 1 head, there's 3 ways. 2 heads, there's 3 ways. And all heads there's 1 way. That would be 3. So 0 would be no heads. 1 would be 1 head. 2 heads, and 3 is our 3 heads. We can use the probability distribution to answer questions about the variable x. This is our distribution, our probability distribution. So, what is the probability that we get at least 1 head in the 3 tosses? Well, we want to find the probability that x is greater than or equal to 1. So, that would be the probability x equal 1 plus the probability that x equals 2 plus the probability that x equals 3, which is 3/8 plus 3/8 plus 1/8, or 7/8. So the probability that we would get at least 1 head is 7/8. So your question is, what is the probability that x is less than or equal to 1? Well, what that means is that would be the probability of getting 0 or 1 head. So the probability of x is less than or equal to 1 equals the probability x equals 0 plus the probability that x equal 1, which is 1/8 plus 3/8, which is 4/8, so 1/2. So this means that this probability means that if we were to repeatedly flip the coin 3 times and record the number of heads, then in the long run, about 50% of the time, we would get 1 or less heads. Discrete variables are distinct, separate values. They're ones that we can count. They're countable numbers. If you're talking about continuous, which we're going to cover a little bit later this chapter, continuous numbers can't be counted. And just because it's random and discrete doesn't mean that it is finite. It could be infinite number, but they're countable numbers. Where continuous are not. They're like numbers, well, I'll get to that later on. Okay, some examples. We could make Y the year that a random student in this class is born. Those are countable numbers. Or we could make X the number of rolls on a fair die needed to get a 6. Or we could have Z the number of ants born tomorrow in the universe. Even though that's not a finite number, we don't have any idea, but they are countable. Those are discrete. If the number is countable, it's discrete. Okay, so here we go. In 2010, here's an example. In 2010, there were 1,319 games played in the National Hockey League's regular season. Imagine selecting one of these games at random and then randomly selecting one of the teams that played in that game. Define the random variable X as the number of goals scored by a randomly selected team in a randomly selected game. The table below gives the probability distribution X. Okay? First of all, let's show the probability distribution of X is legitimate. Well, what does it mean to be legitimate? Well, the probabilities have to add up to 1, and they have to be between 0 and 1. So, all of these are between 0 and 1, and if we added them all up, they would add up to 1. So this is a legitimate distribution. Okay, it says make a histogram of the probability and describe what you see. Okay, so here's our histogram. So describe it. The histogram is skewed to the right, which means that the majority of the games are relatively low scoring. It is pretty unusual for a team to score more than 6 goals. What is the probability that a random number of goals scored by a randomly selected team in a randomly selected game is at least 6? Well, that would be the probability that X is greater than or equal to 6, which is the probability that X equals 6, plus the probability that X equals 7, plus the probability that X equals 8, plus the probability that X equals 9. So if you add up the probabilities, you get 0.06, which means about 6% of the time. Okay, let's check our understanding. So stop this video, go back and read, and check your understanding. Okay, welcome back. Say in words what the meaning of P, X is greater than or equal to 3 is. What is the probability? Okay, probability that a student gets either an A or a B, and it's 0.68. Write the event the student got a grade worse than a C in terms of values of random variable X. What is the probability of this event? Okay, that is P is less than 2. Now remember that it's not equal to, it's below a C. Got a grade worse than a C. A C is 2. So, make sure you understand the difference between less than and less than or equal to. Okay, and if you made the histogram should have been less skewed. Higher grades are more likely, but there are a few lower grades. Okay, so back in Chapter 1, we analyzed the spread, the shape, the center, and the spread, and identified outliers, etc. And we're going to kind of do the same thing with this. with these discrete random variables. Suppose that x is a discrete random variable whose probability distribution is the values x sub 1, x sub 2, and x sub 3, etc., and probability is P1, P2, P3, blah, blah, blah. All right, so to find the mean expected value, which remember we always found the mean, you multiply each possible value by its probability and then add all the products. So this is the formula for it, and I'm going to ask later on, and I'm going to give it to you when you get to that part. So just bear with me. I just wanted to put that in here right now, just for grins, I guess. Okay. So here we go. This is roulette. All right. One wager players can make in a roulette is called the corner bet. To make this bet, a player places his chips on the intersection of 4 numbered squares on the roulette table. If one of these numbers comes up on the wheel, the player bets $1. And the player bets $1. The player gets his $1 back plus 8 more. Otherwise, the casino keeps the original bet. If X is a net gain from a single $1 bet, the possible outcomes of our X equal -1 or X equal 8. Either we lose the $1 or we gain 8. Here is the probability distribution. Okay? -$1 is 34 out of 38, and gaining $8 is 4 out of 38. This is 38 rolls. All right? If the player were to bet $1 over and over again, what would the player's average gain be? This is what we're talking about with our mean. Okay. In the long run, if a player loses $1 in 34 of every 38 games and gains $8 in 4 of every 38 games, imagine a hypothetical 38 bets. The player's average gain is. Okay, so our mu, we add all of our -1s, which are 34 of them, and we add all of our 8s, which are 4 of them, or we could do 34 times the -1 plus 4 times 8 and divide by the total number of games to get our average. That's how we find our average. And when we do that, we get that our average gain is a -5 cents. So for every $1 we bet, we expect the casino to get 5 cents, and we lose 5 cents. So how do you calculate that? Well, I just showed you. And is this on the formula sheet? Well, I did it again. I put it up here. Okay. So you're going to multiply all of these, the P1 times X1, all the way down, and then add those all up. And yes, the formula is on the AP sheet. So it's the sum of all X sub I times P sub I. Okay. How do we interpret the mean expected value? All right. Does the expected value of a random variable have to equal 1 of the possible values of the random variable? And should expected values be rounded? Okay. No. The expected value does not have to equal one of the possible scores. That -5 cents wasn't one of our scores. Our scores were either a -1 or an 8. And 5 cents, a -5 cents was not one of those. So no, it doesn't have to be. And don't lose points over that. You know, don't, make sure you understand that. Does not have to equal one of the possibles. And should expected values be rounded? No. If the mean of a random variable is a non-integer value, but you report it as an integer, your answer will be marked incorrect. So don't round it, leave it. Okay? Yes. All right. So that is your AP test today. All right.